Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to today's webinar, An International Perspective of Plastic Stormwater Corrugated Pipes. My name is Megan Purdy and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them and their cultures and to elders, past and present. Now, before we get started today, I would like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, Iplex. With over 85 years' experience, Iplex has an excellent understanding of the challenges the Australian water industry faces, and their experienced team actively work and collaborate with customers and industry to provide safe, secure, and innovative water solutions today and also into the future. Iplex have broad and proven capabilities and are driven by what is important to them, the communities and their customers, and to provide strong and effective pipeline products and solutions to water authorities, rural and urban agriculture, residential, urban subdivision, civil and mining infrastructure markets across Australia. Now today we'll hear from our keynote speaker, followed by a panel discussion along with, of course, our audience Q&A. So I encourage you all to please send your questions through to our speakers via the chat box. I'd now like to welcome our first speaker for today, Don Tzeski, National Technical Sales Engineer from Iplex Pipelines. Don is a seasoned professional with over 35 years of dedicated experience in the water industry and exhibits a comprehensive understanding of the complexities surrounding water systems, their management, and the critical role they play in our world. Don is deeply engaged in sharing his knowledge, actively participating in industry forums, seminars, and educational initiatives. His commitment to fostering collaboration and driving positive change in the water sector serves as an inspiration to aspiring professionals and industry veterans alike. Please join me in welcoming Don Tzeski.
Thanks very much. Our association with Engineers Australia continues as I welcome you all today for this thought-provoking webinar and expert panel discussion, An International Perspective of Plastic Stormwater Corrugated Pipes. We trust that you will take this opportunity to engage and ask questions and learn from our local and overseas experts. Before we get on to our topic of the day, let me tell you a little bit about Iplex Pipelines. Iplex has been manufacturing and supplying quality products and solutions for over 85 years. We have manufacturing and distribution facilities in most major cities of Australia and employ over 500 people nationally. We pride ourselves on being an Australian manufacturer, and we're even more proud of the countless nation-building projects we've contributed to throughout our history. And that's perhaps how some of you joining us today have come to know us. You could consider that Iplex is an Australian expert in all things piping, and we're here to help you however we can. As you can see, Iplex offer a broad range of products for the civil and infrastructure, irrigation, plumbing, electrical and telco market sectors. Some of you joining us may also have come across our suite of design tools in the Pocket Engineer platform, developed for consulting engineers, contractors and asset owners. The number of applications on the platform are growing, and we value feedback or suggestions to help us continue to grow the platform. Sustainable practices are an important part of our culture, and we continually research, develop and test our products to efficiently manage waste and conserve precious resources. Iplex has established its own stewardship program called Pipeback within participating sites across the east coast of Australia. Pipeback can accept compliant PVC and Iplex pipes, offcuts and fittings, as well as other recyclable products including timber frames and timber scallops that are used in pipe packaging. Sustainability is at our core. So now that you know a little bit more about Iplex and who we are, I want to introduce you to what we're here to discuss as a group today. We're here today to explore our white paper, Global Adoption of Corrugated Plastic Stormwater Pipes, Lessons for Australia, and to engage with the international experts who contributed to its content. If you haven't seen the white paper, I'll give you a few seconds to scan the QR code on the screen. This paper covers the state of play for the use of this style of product around the world, the ease of installation and safety, joint performance, and more importantly, Australian and international case studies, amongst other things. Corrugated plastic stormwater pipes are not new. They're not local. They've been used on massive projects right around the world, from the Punt Road project in Melbourne in 1989 to major international airport projects in LaGuardia and Berlin-Brandenburg, and to the I-270 Missouri Department of Transport widening through St. Louis. These projects highlight speed of installation and cost savings. These products have been used in Australia since the 1980s. We wanted to reinforce how widely used these products are both here and around the world in order to provide confidence to Australian designers and asset owners who may still have questions about the product. These products are worthy of your consideration for use on your projects. It's hard to believe that even nearing 50 years of use in Australia, there may still be questions regarding its use. Councils and other infrastructure managers are facing increasing challenges around efficiency. They're being asked to do more with less, to build faster and more sustainably with a tighter budget. They're being asked to find innovative ways to engage with communities more and disrupt them less, all in a safer and less resource and materials intensive working environment. This is why we're here today. We're here to further unpack the paper in a panel discussion to consider how is twin wall corrugated plastic stormwater pipe being adopted around the world, and what can Australia take from this? Let's dig deeper into their benefits and consider the local and international case studies that were presented. Please take this opportunity to engage with the experts who contributed to this paper, especially our international contributors who are providing their time and expertise to answer your questions today. Once again, I thank you for your participation today, and let's move to the panel.
Thank you, John, for your presentation. I'd now like to extend a warm welcome to our panelists. So what I'll do, I'll begin with Sandra Perez, Global Product Manager for the Infrastructure Pipe Systems Market Segment from Orbia Building and Infrastructure. Sandra is a civil engineer with 27 years of experience specialising in hydraulics and has dedicated over 2 decades to academia, serving as a professor at the Faculty of Engineering from 1998 to 2021, primarily teaching hydraulic constructions. As an author and co-author of academic material, she has played a pivotal role in shaping the education of future engineers. So welcome, Sandra, who's also joining us from Buenos Aires. So good evening to Sandra, I should say. I'd now like to welcome our second, thanks, Sandra. I'd now like to welcome our second panelist, Dan Currents, Director of Engineering, Draining Division from Plastics Pipe Institute. With over 27 years of direct involvement with the corrugated plastic pipe industry, Dan works as a supervising field engineer for Advanced Draining Systems Incorporated for 15 years. Dan actively represents the corrugated plastic pipe industry on the ASTM F17 Committee on Plastic Pipes, CSA B1800 with the AASHTO Subcommittee on Materials, on Transportation Research Board Standing Committee for Culverts and Hydraulic Structures, and is a member of NCHRP review panels for culvert research. So welcome, Dan, who's joining us from the US.
Thank you. Sorry about all those acronyms, Megan.
That's okay. I think I got through, just maybe. I'd now like to welcome our third panelist, Anthony Prodsky, who is president from the Association of Land Development Engineers. Anthony is a leader in the field of urban design and land development with a wealth of experience in engineering, infrastructure planning, and sustainable development, and is dedicated to advancing best practices and fostering collaboration within the industry. As a key advocate for innovation and technical excellence, Anthony plays a pivotal role in shaping policies, driving industry standards, and supporting professionals in the land development sector. So, welcome, Anthony.
Thank you, Megan.
And finally, I'd like to introduce our final panelist, Matt Hines, who's a National Technical Service Manager from Iplex. Matt plays a pivotal role in driving innovation, ensuring quality assurance, and delivering technical expertise across the business. Passionate about engineering excellence and industry best practices, Matt is a proud member of Plastics Industry Pipe Association of Australia and frequently engages with stakeholders, industry professionals, and technical teams to provide insights into pipeline technology, regulatory compliance, and emerging trends. Welcome, Matt.
Thank you, Megan.
So please join me in welcoming all our panelists today, and I'll also, obviously, we've brought Don back in for the discussion. So what I'll do, I'll kick straight into the panel discussion with you all. So the first question I'll direct to, potentially Anthony and Sandra. First question is, concrete has long been the standard for underground drainage. What's motivating some to shift to plastic pipes now? So maybe Anthony, would you like to kick this off today?
Yeah, thanks, Megan. Plastic pipes have been around for a long time. I remember having projects with them in the 90s. But what really brought the shift in Victoria was COVID. When COVID hit, we had a severe material shortage, and we looked for alternatives in what we could use for construction. So that was really the biggest opening for plastic pipes in the land development sector in particular. But the reality is that we're a slow uptake of technology and changes in Australia. So everything that we do here seems to take a long time to get adopted. It's just an alternative. We're not looking to replace. Everything's fit for purpose. So as far as what's motivated the shift, I think the most recent motivation, absolutely COVID, and that changed a lot of things. It changes the way we run webinars, it changes the way that we interact with people. So we can blame it, we can thank it. I think in this instance, we can thank it.
And Sandra?
Yeah, exactly. As Anthony was saying, I think that every technology is an alternative, and each technology has a range of applications fields. That is where these technologies are better. In the regions that I'm working, mostly there is Europe and Latin America. The shift, there has been for some decades a kind of a trend for shifting to plastic solutions, and this has to do with many reasons, but mostly it has to do with some advantages that sometimes the plastics brings to some projects. So for instance, we can have lower installation costs because the pipes are less heavy and they are easy to handle, so we can have quicker cost-effective installations. The water tightness is another very big advantage of plastic solutions. Usually plastic pipes offer excellently proof-showing systems, but also the length of the pipes is longer. So we have 6-meter pipes, so that means that we have less potential leak points in the systems when they are made of plastics. Also, plastics brings a very good corrosion and chemical resistance and outstanding hydraulic performance because of the smooth surface inside the walls of the pipes, and also the flexible behavior of plastics. Once you get to understand how this works, you can easily see that it brings a lot of advantages and is a very safe way of resisting loads. Also, the durability of plastics. These pipes are usually designed to last for between 50 and 100 years. So, and even when they have to be replaced, they are recyclable. So they can also there are some environmental and life cycle considerations being taken there. And another reason is usually the fact that there is a lot of innovation and constant product development around plastics. You can see all plastic manufacturers always looking and investigating and looking of ways of optimizing their products and comply with customer needs. So there are many reasons why this is more or less a trend, but as mentioned before, it depends on each project. Each project there is a technology that is the match for each project. So plastics for us is another alternative that is good to consider. Many times it has a lot of advantages, but it's good to be confident that this is a good solution. And that's why that is what is happening, at least in the regions where I'm working.
Thanks, Sandra. Well, probably from that, so what are the challenges that not just engineers, but what are the challenges that engineers, contractors, and developers, what are they actually addressing with the plastic alternatives?
I think that for me, at least in my opinion, what I see is that the main challenge for engineers that are used to install concrete pipes, for instance, is to understand that plastic pipes works in a complete different way to resist loads. So when you don't fully understand this fact and you try to analyze plastic pipes the same way you usually analyze concrete or other materials, then things can get confusing and distortive. So another challenge also for contractors, I think, is that when they are used to install very stiff and heavy pipes, switching to these very lightweight and thin wall products can bring some insecurities. And many times there is this misconception that the heavier and the stiffer the pipe, the more resistant it is. So in this case, it's important to understand that there are decades of experience with these pipes worldwide, and that experience shows that if you follow the easy instructions given by the plastic pipe manufacturers, you won't have any problems. So I can tell you that once they get used to it, they understand the advantages, and yes, they adopt it right away. But I think the main challenge is to understand the differences between the different technologies.
Excellent. Great answer.
If I can add to that, Megan.
Please.
I think one of the challenges, and I talk locally about what we do, is authority acceptance, because we as engineers, we've got the tools there, and we have the knowledge to design, and we can problem solve, but we need them to comply solutions and specifications that actually allow us to install or allow their product to be used. As far as understanding the parameters and stuff, a lot of our services now are forced into the roadways because we haven't got space in the rear of allotments and the like. So we're using crushed rock backfill regardless, which is good for these products because of the way the load's distributed in the soil profile. As far as private industry, like they're picking it up and running with it because hydraulically they're more efficient. So the challenge definitely for engineers is industry acceptance and having the ability to actually specify it in all areas, not just under footpaths or in nature strips. For the contractors, I think the contractors, they need to be more aware of the installation techniques, and because a poorly installed pipe won't perform, doesn't matter what it is. So and everyone always remembers what fails. People don't usually remember what works well. It's always a failure which is getting the headlines. So that's for the contractors. And the third part of your question was developers. Well, I think developers will always seek a least cost but appropriate solution. So if we are allowed to use them and we know how to install them, the developers will go with it. So there's my tip.
Great answer, Anthony. Thank you both. Well, probably, if we go into maybe doing a bit of a deep dive onto the pipes. So maybe Matt and Don and Dan, we'll kick off with Matt. Could you maybe just run through the actual structure and the performance of the twin wall corrugated plastic pipes?
Yeah, sure. Okay, thanks. So essentially, the structure of a twin wall pipe is exactly that. It's two walls, right? So we have an outer wall, which is a corrugated layer, and we have an inner wall, which forms a smooth bore layer of the pipe. Now, we've got a cross section here, which I hopefully, if I hold up and everyone can see, so it's pretty self-explanatory. You've got the outer corrugated layer here in black, and the inner smooth bore layer here, in which the stormwater is going to be in contact with and transported through. And that's the basic construct of a corrugated twin wall pipe. So the corrugations in this case provide a lot of the structural integrity, the stiffness to the product, but it's intimately welded to the inner layer as well, so they work in conjunction with each other to provide that stiffness and that structural integrity. But at the same time, and importantly, as Sandra mentioned, flexibility. So flexibility being the key here. The other aspect of the corrugated drainage pipes is there is an integral joint system that's formed during the manufacturing process. So that's connecting socket and spigot of the pipes together. And design of that is critical to the performance of the product and its ability to flex, that joint to flex, and the seal ring design system as well takes into that account to allow for the system to seal when it is being deflected, so it can cope with sorts of groundwater types of situations, so you don't get any infiltration into your stormwater system, and also any exfiltration. Of course, you don't want water getting out into the environment. It has to be contained in a complete integral type of joint system. So that's sort of a high level sort of overview in terms of the structure of a corrugated drainage pipe. So in terms of performance, again, this flexibility is the key. The ability for the pipe to flex and distribute those loads to the surrounding soil in the case of a buried pipe application is one of the key design features, and as Sandra said, something that engineers need to get their head around in terms of the differences between buried flexible design and rigid buried design. They're quite different. And now I think I'll hand over to Don if you want to take a little bit further.
Well, thanks, Matt. I'm not sure what I can add to that excellent explanation there. You did mention the outer corrugations. They provide stiffness to the pipe without increasing weight. So we're able to reduce weight and then still provide a very strong, stiff product. And that allows us then to cater for heavy loads. It allows us to cater for different trench conditions. It allows us to cater for different water conditions through the project or through the soil. So I can't add any more than what Matt's already provided. Dan, is there anything you can add to that?
Sure. Yeah, happy to. I think Matt mentioned that the inner liner is primarily for hydraulic performance. I mean, it improves the hydraulic flow, which Sandra talked about. The other thing that it provides is beam strength. So if you didn't have that inner liner, you would have to worry more about line and grade. With the inner liner, these are sticks of pipe, and so it really provides that consistency in the 6 meter length that was discussed earlier with bells and spigots. So it does provide a very consistent system. The other thing that I would point out, and this gets back again where Sandra was talking about the difference between rigid and flexible pipe design, we in North America refer to a soil structure interaction system. And that's frankly for any type of pipe. Every type of pipe that is buried is interacting with the soil around it. It just so happens that a flexible pipe has more interaction with the soil than a rigid pipe, but a rigid pipe is part of an interaction system, or otherwise they would have zero installation guidance. It wouldn't matter. But we all know that there is installation guidance for rigid pipe. And so with flexible pipe, that interaction is more important. Getting the appropriate backfill is important, and obviously using a crushed rock that was mentioned earlier makes that go much smoother. But it is a soil structure interaction, and that's really what gives the pipe the ability. There's no different classes of pipe necessarily. It's one pipe can go 300 millimeters deep, or it can go doing my conversions, it can go 20 meters deep. I mean, it's the same pipe that's under those circumstances, and the difference is how it interacts with the soil. In shallower installations, it's important to get it there's less soil above it. But with deeper installations, there's more transfer of the load to the surrounding soil. So the pipe in a deep installation never experiences the entire soil column that's above it. It's shedding that load, passing it to the surrounding soils, and that's what gives it the ability to either go deep or shallow, same pipe, suitable for all those traffic conditions.
And maybe I can add. Oh, sorry, Megan. No, I wanted to add something to what Dan was saying, because I think it's interesting linking with what I was saying before about the constant innovation around plastics. And I think this is a perfect example of it, because you can tell how the wall design of the pipe is everything in the wall design is meant for something. So the inner wall is meant for hydraulic capacity. The corrugation is meant to provide ring stiffness to the pipe. The design of the joint system is especially designed to be able to guarantee watertightness. So these pipes are really very designed with a lot of details, and you can tell that every part has a reason for something. So this is one that I wanted to point out. And the other thing has to do with the installation, as Dan was mentioning. One thing that is a huge misconception when comparing flexible pipes with rigid pipes is that flexible pipes needs a lot of attention when it comes to installation. And that is, to be honest, that is not true. Both type of pipes needs guidance. You need to comply with certain requirements when you install them. The thing is that what we do it for is for different reasons. While in the flexible pipes, we do it because the soil pipe interaction is crucial for the resistance of the package, of the full package soil and pipe. In the case of rigid pipes, maybe it's more to prevent soil settlements, differential settlements that may cause fractures in the pipes or something. But in both cases, we need to have special care when we install them. And so it's not true that in the case of flexible pipes, we need to be more careful. What is true is that if we install a flexible pipe following the recommendations, following the instruction, is happening what Dan was saying. This flexible pipe is able to sustain, to be buried at very deep depths without and performing perfectly. Because remember, if you install properly a flexible pipe, what you get is that the pipe is transferring the load to the soil. So the system is able to sustain really high loads without any problem and in constant in time. So that's what I wanted to add. Sorry.
Thanks, Sandra. Well, probably the next question I'd have would be, so what standards or compliance measures should engineers be aware of when specifying these pipes?
I can jump in here, Megan, in terms of standards. Yeah, no problem. So in terms of standards, what engineers really need to be aware of is what is the appropriate product standard. So in the case of Australia, we have a standard AS/NZS 5065, which covers corrugated drainage pipes, or drainage and for sewage applications, right? And it covers the twin wall design, and these standards specify this standard specifies key properties that are required to ensure that products, you get the service life that you're expecting. So if we're expecting 100-year service life, then you need to select products that are manufactured in accordance with the AS/NZS 5065 standard, because it defines things about the materials, key properties that the materials have to have, and key properties that the final product has to have. And that's obviously things like the stiffness, so that the stiffness number that you're going for, and the ring flexibility. So its ability to sustain quite significant ring deflection. So there's a test we call the ring flexibility test. which deflects the pipe up to 30% of its inside diameter, and it's required to, and that's quite an extreme test. So you're required to squash the pipe, 30% deflection, and there should be no permanent deformation or buckling or delamination of the two layers. And it just shows its ability to withstand these very high strains. Okay, and that's a real key property. Of course, there are tests around the joint performance, right, that we sort of briefly alluded to before, in terms of its ability to resist infiltration of groundwater and also exfiltration, and that's also done at tested at positive pressures and negative pressures. So we typically test our joints up to sort of minus 80 kPa or positive 80 kPa in the case of the 5065 standard. And the joints are also tested in a deflected state to make sure that whole rubber ring socket spigot interface system works correctly and performs right in the field at some extreme deflections. So there's quite a bit of safety factor that's brought in to the design. So the key is, engineers, you need to be aware of the appropriate product standards and make sure products are being specified against that standard. So in this case, ASNZS 5065.
Thanks, Matt. Jumping into, because we've got an international panel here, I was just really interested in probably tapping into just understanding, the trends that we're seeing. So obviously across Australia, but then also how does that compare to what's happening in international markets? So maybe Anthony, if you wanted to kick off with the Australian perspective.
Yeah, so look, from what I see and witness, in our residential construction is fully flexible pipe. It has been for some time. So it wasn't that long ago we had concrete and VC pipes in the residential sector. Pretty much all of our industrial clients now are using, a plastic or a flexible pipe for all the drainage internally. So private industry has definitely picked up and on board, and for all the reasons about ease of installation and transport costs and bits and pieces. As far as authorities go, the trends we're seeing is slow adoption, and also we get conditional approval. So the conditional approval actually makes it quite difficult, because then you have to start specifying some plastic or some flexible, some concrete. And when you have conditional approval, it means that if it's not approved under pavement, where do you stop and start that pipe run? What happens if there's a future road connection? And then a lack of understanding means that a conditional approval is likely that pipe might have to be removed in the future if it was approved on the basis of only behind back a curb, for example. But definitely the strong trend would be that we're saying it adopted anywhere that is a private owned development or privately funded development. But where we're seeing it, where infrastructure is gifted to an authority, we're still seeing a lot of concrete installation or conditional approval.
Thank you. Maybe Dan?
Yeah, I can share some perspectives from North America. I mean, we've been working at this for years. My whole career has kind of been working in that area of trying to expand acceptance. And in the U.S., we start with national standards. There were several standards, Australian standards shared. We use ASTM standards in the States and in most of North America. So we have ASTM standards, and then probably the next kind of tier of, once we have those national standards for material, for installation, for design, then the next thing that we try to pursue is with highway departments for culvert and drainage use in the States. Getting approval at the state highway department is an important step. And so we pursue those approvals. And so that sometimes they come up with unique expectations, something a little bit different than the national standard, but trying to get the state approval. And then you go from the state approval down to a large urban city or county jurisdiction. And in each of those steps, kind of what Anthony is talking about, we have we have places across North America where we have zero approval for corrugated plastic pipe. We have places where we have conditional approval, as Anthony was talking about, and then we have places where we have full approval, where it's competing on completely equal terms with every other product. And so there's no, if you have a map of North America, there's no thing that covers it consistently. Probably the most consistent thing, and Anthony kind of alluded to this, was the private development. In private development, that decision in most cases is up to the design engineer. And the design engineer, once they have the specifications that they are comfortable with, then they can specify it. We also have projects who are then turned over to a city jurisdiction, but that's usually governed by the city. So private is very, very broadly approved. We have some public agency that is broadly approved, but then we have conditional, and then we still have some areas where there's no approval. So it's kind of a mixed bag, but it's very dependent upon the jurisdiction.
Thanks, Dan. Sandra, did you want to add to that?
Yes, I can speak about something about Europe and Latin America. In both places, plastics are today more than 60% of the infrastructure, drainage, and sewer pipeline market, and they are growing. They are taking bigger shares in time. Has to do with what we discussed earlier, but concrete. There are other materials, mostly concrete, that are used, but these technologies are mostly used for very large diameter applications. When it comes to small to medium diameter applications, concrete, we can see it gradually declining as plastic systems are the ones being used for replacing older networks, and for new construction. In the case of Europe, this is also encouraged by local regulations towards sustainability and recyclability, which reinforces this shift to plastics. And that's why you can see most of the plastic manufacturers in Europe now developing and fighting for developing the lower carbon footprint products possible. So this is what is going on in Europe. In Latin America, this is not that an issue. Sustainability is important, but it's not that important. And in Europe, but anyway, plastics have a very big share of the market, especially the same as in Europe for the small diameters. And they are growing. Twin wall technologies are very strong in Latin America, very strong. They are performing very well. We have, for instance, a technology that we only have in Guavin in Latin America. We are in 12 countries, and we had this product being installed in more than 150,000 kilometers and for 30 years in 12 countries, and the products have always performed perfect. So there is such a good experience that the market is usually choosing this type of pipes, not only because of the advantages we mentioned before, but also because twin wall pipes are usually more cost effective when it comes to the product cost also, not only the installation, but also the product cost. So especially in Latin America where resources are lower, this allows them to run longer projects with the same budget. And that's why they are usually going for it. So this is more or less the picture for these reasons.
Thank you. Did anyone else from the panel want to add to that?
I'll just add, I guess, as far as the trend, we are seeing growth in corrugated plastics pipes in North America. We continue to grow, and we are also growing with polypropylene. High density polyethylene is the primary corrugated plastic pipe used in North America. Several companies have introduced corrugated polypropylene pipe, and that has been seen very favorably. So the addition of polypropylene has also gave us new opportunities in new areas. Sandra mentioned the use of recycled materials in high density polyethylene. That's created an opportunity as well for those interested in carbon footprint on projects and things like that. So we do continue to see growth. There's plenty of growth that still is out there to be achieved, despite the success we've had so far.
Thanks, Ben. So, understanding, there is the trend towards the plastic pipe. So, what are the common barriers, or what are the concerns regarding these pipes, and how are they being addressed? So maybe Anthony or Matt, did you want to jump in?
I can chime in there. So as far as the barriers mostly is industry acceptance at an authority level. And the way they're being addressed is usually by some sort of trial. Someone wants to say, when we try it here? The problem with the trial is sort of that ongoing, observations or, data collection doesn't really happen. So it's a trial, but then it's usually forgotten. With conditional acceptance is something that's happening, but again, I'm not an advocate for that because it tends to complicate it. But as far as private industry goes, we're seeing much bigger distribution centres, warehousing, commercial centres. So a lot more roof space, a lot more downpipes. So it's almost it would be the go-to for all of those sort of buildings. So I think the fact that industry is getting more familiar with installing it is going to assist us going forward.
Yeah, I would agree with that. I think probably it's almost goes without saying, but for a lot of people, the expression is "we've never done it that way before" is a very real barrier, and they almost stop there. Now, they may give reasons why, but it really comes down to because they're uncomfortable doing it any different way than what they've done before. And so it's part of our job as an industry and to do things like this, to educate, to make people aware that in no way are you the guinea pig or trial balloon in these applications. There have been plenty out there over the years with years of documented support. So with that, I guess other barriers, Sandra mentioned the concern about can you get proper installation? And that, again, that is usually an objection that comes up, but it's really not that hard to overcome because contractors can install pipe correctly. It's not that difficult. So yes, initially that becomes a barrier, but that one is quickly overcome as well. So I think those are probably the two most common is we've never done it that way before and concerned about installation.
Yeah, and maybe to add to that, I think that it has to do with what we've been discussing already, that the biggest barrier for me comes from the lack of knowledge about plastic pipes and their flexible behavior. So there are a lot of misconceptions in the market, thinking that if the pipe is not rigid or it doesn't have such a big ring stiffness, it won't resist load, that is too difficult to install, that is the flexibility is a disadvantage, where is when you come to understand how flexibility works, you understand that it is an advantage and not a disadvantage. So there are all of these barriers are easily manageable by only information, education, trainings, and make people understand and be sure that it is completely safe to install plastic pipes. You just need to analyze them in a different way as you are used to. to do with rigid solutions. That's it. But I think that is the main barrier right now.
Thanks, Sandra. Well, maybe what we could do now is jump into if the panel would be open to walking us through a couple of projects where plastic stormwater pipes were used. I think, understanding that, we've got some actual applications of the pipes. So do we have someone who'd like to kick off?
I can kick off, Megan.
Yeah, awesome.
I'd like to highlight one of the projects that was mentioned in the white paper. It was the Punt Road project here in Melbourne. It was installed in 1989. There was DN 1200, DN 1500 and DN 2100 diameter pipes on that project, and they went along the road and traversed across the roads at Swan Street and Punt Road. And for people that are in Melbourne will know what sort of traffic volume Punt Road takes each day. These pipes were installed, particularly the 1500 and the 2100 diameter pipes had pretty low cover, about 550 millimetres of cover over those pipes. And the pipes have been inspected twice since they were installed, first in 1999, about 10 years after installation, and the last time in 2020. And that was about 30 odd years after installation. And to no one's surprise, the pipes are still in excellent condition. The pipes are still in the same condition that they were installed. Deflections are still the same. There has been some monitoring of those pipes over that 30 odd, or what is it now, 35, 36 years of installation. And they're still in excellent condition. There's another project at Berwick, Hillcrest College at Soldiers Road. I am local, so I know about these projects. There was some DN 300 diameter pipe installed by Casey City Council, and the cover on top of those pipes was less than 100 millimetres. So I don't know if you can see the screen, but we're talking about a cover of this much, a very low cover. These pipes were placed in a swale, entrance and exit to the college. They were traversed by buses, garbage trucks, maintenance vehicles on a daily basis, and those pipes were in service for over 15 years. That whole area has now been developed and there's no need for a swale drain, but those pipes certainly showed the impact resistance of corrugated pipe, as well as the high strength. And once again, no surprise, the pipes didn't buckle, the road didn't collapse. And I think, as Sandra said, there is a lack of information, or a lack of understanding is probably a better word for flexible pipe and flexible pipe design in our industry. I'm sure that there's other projects that Dan and Sandra can talk about. There were certainly a few in that white paper.
So should I go to you, Dan? Did you want to take us through?
Yeah, there's a variety of projects where plastic pipe has been used in a, I guess, kind of noteworthy place. Don mentioned I-270 in Missouri. There was a large project, over 12,000 meters of pipe used on a interstate roadway in South Carolina. A more recent project, I know that we just awarded our project of the year to a project that was completed in Tampa, Florida, in conjunction with a very large bridge, and it had I think over 3,000 meters of plastic pipe used in conjunction with it. Those are some of the more noteworthy ones. Some of the things that really highlight the value of corrugated plastic pipe. There was a project at a shipping terminal in a coastal area where they used it for the drainage project, and it was selected because the soils in that area were very unstable, and they were concerned about putting a rigid pipe into those unstable soils because it might sink. And so they actually selected and only allowed corrugated plastic because uh, of its lightweight and because of the fewer joints and the joint integrity. And so all those things played a factor, and it turned out to be a very important part of completing that project. So there are those types of projects. Every pipe type has its strength, of where it should be used. But there are some where plastic sometimes is the only choice, whether it's corrosive soils in a coastal area because of salt water is another one. And that project in Tampa, Florida would speak to that also, because that was one of the selections. They were concerned about the caustic impact to other pipe materials. So anyway, those are some of the ones that I would point out. But we have cities, states across the region, so it just kind of comes down to what type of project are you interested in, and we've probably had one like that. Airport projects, we've been used under airports in the States as well.
Excellent. And Sandra?
Yes, I think I already mentioned, maybe not a specific project, but we have a lot of experience, especially talking about twin wall pipe systems. We have a lot of experience. In Europe, we have polypropylene systems, and we in Latin America is more oriented to PVC. Latin America is a region that likes PVC a lot, and also polyethylene. But these twin wall pipe systems, as I mentioned, they have been installed for 30 years in our region, more than 150,000 kilometers. And we have a record of 0 failures. So the pipes never failed. They behave perfect. Even for with the installations here in Latin America, maybe in some places the installation is not the best. Sometimes contractors do not know exactly how to install a flexible pipe. And even though we had some bad installations, the pipes always perform very well. So I think that is a great example of how these plastic solutions are a very good alternative for the projects.
Excellent. Thanks, Sandra. Well, what I might do is I'll start bringing in some of the questions that we've received from registration. So when you do register for these events, that you've got the opportunity to submit a question at registration. So a big thank you to those people. And also I can see a heap of live questions coming through. So I wanted to start bringing our audience into the conversation. And really I saw it, came through, and I think the guys have everyone on the panel has touched on, how the pipes are being installed, are they being monitored? And I think we've touched on that just then. So, and I could see that came through. Chris Higgs watching live, I saw that you just posed that question, so I hope we answered it straight away for you. But what I might do is go into another question which came in from Neil in Queensland, and I might direct this one to Anthony. And it was, why are plastic pipes not used so much in drainage in Australia, where in the UK, when the UK rarely uses anything else for typical stormwater conveyance?
Look, again, for me, it's just the authority approvals. The private industry is definitely using it. If you go to any large industrial site internally, it'll be plastic pipe that's installed. All residential, all owners corps, it's all plastic pipe. So it's just if we can convince, and even today we're having a discussion today about the merits of plastic pipe. I think we all agree now that we should agree at least that plastic pipe is an alternative, and that's all we're looking for, is to get awareness that there's alternatives out there. and not to be scared now at this time, this point in time, to start really looking at the alternatives. So the contractors, they're becoming more skilled in what they do. Like we're going to have to see changes in what we deliver into the future, not just in pipe network, but in footpaths and roads and everything. So I know the CCF in Victoria in particular is looking at, formal training for like recognised training as an apprenticeship. So, having pipe laying as part of that apprenticeship course, and it should get up because it's warranted, would be really handy, because then, someone's an actually accredited pipe layer. They've done some training. They've got a more of an in-depth understanding of how the pipe performs and what it needs to do in the installation process, because it's the installation process. If it's done poorly, it really makes the council stop and think, oh, this is not the right product. And it's not because the product's no good, it's because the installation hasn't been done properly. Not sure I've answered the question. I've digressed a bit there.
Thanks, Anthony. I'll move on to the next question, and this one's from Robert in Queensland. So, hi, Robert, and I might direct this to you, Matt.
Sure.
How has the design life been estimated, and has it considered how plastics become more brittle over time?
Okay, so design life, in the case of non-pressure buried applications, is based on a whole host of factors, and one of those I mentioned before was factors that are covered by the standard, right? In this case, the ASNZS 5065. So the standards define all of these properties that the materials are required to have and the finished products are required to have, and they are really key in terms of defining, a design life in many cases of 50 years is typically an industry standard for what we work to in terms of design life. And that doesn't mean that after 50 years it's no good, it falls apart or anything like that. Far from it. It's just the design basis which has been adopted by industry sort of pretty much worldwide when it comes to the design of plastic pipe systems. They can obviously have service lives that go well beyond the 50 years, and 100 years is quite normally stated, right? But yeah, coming back to how it's been estimated based on understanding how the various materials behave, so that whether that's HDPE or polypropylene, specifying key material properties that ensure that long-term performance. The comment there about degradation, one of the properties that's covered in terms of degradation, and this comes down to the specification of the material, is a thing what we call thermal stability, and this comes around to specifying the stabilizer package that's part of the materials, whether it's an HDPE or a polypropylene. They have an onboard stabilizer package which consists of various antioxidants which prevent degradation of the polymer. So provided the right antioxidant package is incorporated into the material, and that's incorporated by the polymer manufacturer, whether that's the polypropylene polymer manufacturer or an HDPE polymer manufacturer, and that ensures or protects that polymer from degradation in service, whether that's degradation because of thermal effects or sort of UV type exposure. Those things are covered in the design and specification of the correct materials. So again, standards, very, very important.
Matt, off the back of that, Ben, who's watching live, so hi Ben, had a question. You may have answered it, so my apologies if you didn't. But is there a concern regarding microplastics being dislodged due to abrasion over time?
Okay, I'll jump in here, Megan. So yeah, microplastics is a very topical discussion point at the moment around the traps. Various studies have been carried out, and a lot of this is really in its early stages in regards to microplastics. But there has been work undertaken by TEPFA in Europe, which is the Plastics, Pipes and Fittings Association that applies in Europe, and they've looked at microplastics in regards to drinking water type systems, and whether they occur in drinking water systems, whether it's PVC or polyethylene or whatever particular plastic material is being used for the transport of potable drinking water. And in their studies, they've certainly found that is definitely not a concern. They haven't been able to detect any microplastics in that case. When it comes to stormwater, obviously we've got other materials that have been transported through stormwater, and there's a possibility that there could be some sort of abrasion. Studies on stormwater pipes that have been exhumed from service. TEPFA also carried out some of this work in which they sort of looked at potential reductions in the wall thickness of the pipe. So if there's been a reduction in wall thickness, that would suggest there's some sort of abrasion occurring. And those studies show essentially in what they looked at the time in terms of a stormwater case, then they didn't detect any loss in wall thickness, suggesting that there was no microplastics. But of course, we know in other applications like slurry lines and things like that, where there's a high loading of abrasive materials, then you will get material wear occurring, right? So it's going to be dependent on the medium that's being transported through the pipe. And this is an area that we're sort of, from an industry perspective, looking at further, and looking at carrying out some future work in this area in regards to microplastics in stormwater type systems. But yeah, good question. Thanks.
Thanks, Ben.
Can I just add to that, Megan?
Of course.
So Matthew was talking about wearing. There is Darmstadt testing that shows that polyolefins, polyethylene and polypropylene, have better wear resistance than concrete. So in terms of abrasion, you'll find that these types of pipes will abrade less, or you would hope that they would abrade less than concrete does.
Thanks, Don. Don, while I have you, there are a few questions which have come through that you might be best suited to answer. The first one came through from Duncan, who's watching live, and it was, is there any developments or products that would allow for the installation of the pipes in areas with construction loadings that would allow less than 750 millimetre of cover?
Yeah, thank you. That's a very good question. Thank you, Duncan. In Australia, there's a few standards that we use, typically AS/NZS 2566 Part 1 being the main standard. It allows you to calculate loads on pipes, and certainly construction loads can be calculated over pipes. I help designers, or I interact with designers every day, and 750 mil cover is very good cover. If you consider that Punt Road project that I mentioned earlier, it had 550 mil cover over the 2100 and the 1500 diameter pipe. 750 mil for most construction equipment is certainly achievable. If you reach out, I can certainly have a chat to you after this panel discussion.
Thanks, John. There was a statement which came through, but I could actually see a few comments on the live chat today, so I thought I'd put it forward. I know we've touched on it in the panel discussion, but I was just hoping maybe for our panelists to provide, just to kind of some guidance as for our viewers as what they can do. But the statement is, and it's come through from Matt Klein, the issues our local councils have in allowing plastic stormwater pipes is poor installation by contractors. Whenever it's been allowed, it's been installed poorly, particularly at the joints. So I was just wondering if maybe we could, just touch on some points, some takeaways for them of what they can do there, but then maybe any personal experiences that you have with this and how best they can deal with these issues. So I'm opening it up to the panel. Who would like to jump in?
I can maybe start.
Sorry. Thanks, Sandra.
No, I was going to say that, yeah, this is a problem that is really that often occurs all the time. We have this problem with whatever reason you talk about this, they all have this problem. Contractors not complying with the installation recommendations and ending up in poor installations that, of course, then result on the pipe being deformed more than it needed to, and this brings all the alarms. And so the first thing that we need to understand is that, again, we need to understand flexible behavior of the pipes. So there is this thing when a pipe deflects too much, more than 5% or 6-7%, and immediately people start to panic. Because of course, with other solutions, with other technologies, when you have this kind of deflections, you immediately have the breaks in the pipe, fissures and fractures in the pipes. That is not the case for flexible pipes, and usually thermoplastics as PVC, polyethylene, polypropylene, they can sustain really big deformations without having any structural problem. That's why earlier was mentioned that these pipes have to go through what we call the ring flex test, that is requiring the pipe standards. And this test is to consist on deflecting the pipe by 30% and making sure that the pipe is still stable. So that there are no delaminations or nothing that will compromise the structure of the pipe. So you can see that even when they are poorly installed, the pipes are capable of resisting these bad conditions. However, we don't want them to be installed so poorly. We don't want them to reach this kind of deformations. So it is very important to have a lot of training of the contractors. I remember that some time ago, when I was working as a technical advisor here in the company for Argentina, my job was every time we sold the pipes, I would go to the contractor, sit down with them with our installation manual, and make sure going with them step by step, making sure that they understand what they needed to do. And many times when we had a contractor that we didn't trust so much, we had people visiting the work site not every day, but very often, to make sure that the installation was being done properly. And if it wasn't, we will go to the owner of the project and we'll let them know that they need to be more careful. Or maybe we will go to the contractor and ask them to be more careful. So I think that at least at the beginning, after we have a more deep understanding on how these pipes have to be installed, you have to be there with the contractor, with the clients very often, and make sure that they understand how to do it. And especially the importance of doing it well, because if they don't, flexible pipes immediately say I'm being poorly installed because they immediately deform. So for the installer, it's going to be a headache because they will need to restore things, they will need to fix it at the time. So it's better for them to understand to do things properly from the beginning, so they can avoid these kind of headaches.
And Megan, if I can add, sorry.
I'll go, Anthony, if that's all right. Just to play off of what Sandra was saying, I think the fact that corrugated plastic does show whether it was a proper installation relatively quickly is a positive thing. Before the contractor leaves a job site, you'll know. And hopefully, as he installs some of his first pipe, he'll know. But just as far as some real practical things that in my years of experience that I would encourage, One is to have a trench detail in the plans every time. A trench detail that shows the pipe, that shows the bedding, that shows, the notes of backfill materials, compaction levels, all that in the trench detail. A lot of times it's in the specifications, and the person in the trench isn't carrying the specifications, but they do have the plans because they have to worry about elevations and line and grade. And so having that trench detail in plans is one of the things that we always encourage. One of the other things that comes up, and Sandra mentioned it, was having a pre-construction meeting, especially a requirement to have it, especially if you're going into a new area, new jurisdiction, for example, is to require it, and to require that a manufacturer's rep or the engineer be present to discuss that installation procedure so that everybody can see, oh, this is what the trench looks like. This is the backfill material he's using. What compaction equipment does he have on site? And they can look through all those things, discuss it, and that generally helps as well. I think that's better. There are some places that will suggest that you want to have a certified installer. I've never found that to be a great system. It works initially, but nobody keeps up with it. And you end up having a different crew, a different superintendent on the job, and it's just unreliable. And so that's why I would rather have the pre-construction meeting on the site and require that you see the first initial whatever feet, 25 meters of pipe, whatever it is, comes some number that has to be observed. And then, like I said, then it tells you very quickly if he's doing a good job. Then the third, so the trench detail on-site meeting, and then the third thing would be post-installation inspection. And this doesn't have to be anything extensive. It can just be that an expectation that, hey, we're going to shine a light down every one of these runs and give it a look, because plastic pipe tells on the installation so quick. That's a great system, and you can do that very quickly to see how well he's controlling line and grade, see what deflection looks like. You can even get some sense of how well the joints are coming together. So that's a simple post-installation inspection. A more detailed inspection, whether it be video or pulling a mandrel through, I would never want to put the burden of 100% of a project. But initially, if you want to say a random, the inspector may choose 10% of the job to and call out for a mandrel to be pulled. That's an incredible deterrent against improper installation. So those are my levels. I would say a trench detail, on-site conversation about installation, and then the next course would be some type of post-installation inspection. And again, those three things are good for any pipe material, but especially for corrugated plastic.
Sounds great advice. Anthony, did you want to add to the answer?
Actually, Dan touched on it on that last point, is the CCTV inspection, because the CCTV inspection is the tell-all of the installation technique. And I wouldn't be scared of specifying it for 100% of pipe, because ultimately it's an insurance policy for everybody involved in the project that the job at completion was done properly, because there's many instances, especially when you do authority works and there's opportunities for third-party access to the road reserve or something later on. There's nothing stopping someone else coming back later on and doing something which is going to be detrimental to that pipe. So having that evidence that it was installed correctly gives you that insurance that you can go back and hand on heart and say, well, when the job was finished and handed over, it was in a perfect condition. And the contractor only prices to do things once. So if the CCT comes back and the pipe's failed, doing it a second time starts to hurt them, and they'll learn very quickly that they can't keep doing that.
Excellent, thank you. Well, I've got a couple of really specific questions which have come through from our live audience, so I might direct a couple of those through to Don. The first one, Don's from Matt, and his question is, how do the pipes deal with vegetation, root intrusion at joins, and the ongoing maintenance, jetting, and root cutting equipment?
Thanks, Matt, for that question. I would imagine in the early 1990s, the CSIRO here in Australia conducted testing for tree root intrusion or root intrusion into joints, and they used a variety of different pipe materials. And what they determined was that if you had an interface pressure between the rubber ring and the socket of the pipe, and if that interface pressure was 0.4 megapascals or greater, then that was a deterrent for tree root intrusion. And that requirement has been placed into many of the Australian standards that we use for water and sewer or non-pressure applications. So that's how we deal with tree root intrusion, and you'll find that plastic pipes, whether they're PVC, polyethylene, polypropylene, they don't sweat and they don't attract tree roots, whereas pervious materials attract tree roots and then they attack the joint. In terms of root cutting, locally, the Whitehorse City Council back in the early 2000s did a root cutting or a root cutting trial on some of our pipes, and they were very impressed at the durability of the pipes after the tree root cutter had been through that pipe. So there's been a fair bit of work done in that area, Matt. Thanks for your question.
John, I'll keep the questions coming to you. I saw that we've got a couple of questions. One came through registration and one came through with the live audience. So hello to Ahmed. Really around the comparison of plastic pipe to concrete pipe. So any insight, I suppose, on the design life comparison between the two. And then also the question was around decommissioning of plastic pipe.
Yeah, thank you. Thanks for the question. The design life, I think Matthew touched on a design basis of 50 years for flexible pipes that's used worldwide. And really that's just to determine the long-term properties so that you can take creep into account. In terms of the service life, a plastic pipe or an Iplex plastic pipe certainly could have a service life in excess of 100 years if it's designed well, if it's manufactured well, if it's installed well, and if it's maintained in accordance with the manufacturer's instructions. So, let's not confuse design life and service life or expectation of life. The second part of that question was decommissioning of plastic pipes. All thermoplastic pipes, whether they're PVC, PE, polypropylene, are fully recyclable. And I think Matthew would probably be a better, could have a better indication on how many times you can recycle a polyolefin pipe, but I think it's in the order of 6 to 7 times. And if you use that example of, up to 100 years, so, you could be looking at 600 to 700 years of recycling for that same material. Matt, do you just want to correct me on that? I'd hate to be telling porcupines here.
You're on the money, polyolefins are certainly fully recyclable and they can go through a number of reprocessing cycles, and as you said, 6 or 7. And if we consider a service life of, as you said, 100 years, then we're looking at 600 or 700 years of service out of that material, right? So that's pretty amazing in itself. I mean, when it comes to decommissioning of pipelines, the other thing is to be mindful of is you don't always want to extract them out of the ground if they're buried, right? If there's no longer used, you've got this useful hole in the ground, and sometimes, on occasions, they can be used as a host pipe for other services, right? So it may still remain in the ground. It might be decommissioned. It might be just left in the ground. You've got to consider the environmental factors of removing a pipe from the ground and what's involved and costs. But sometimes you can reuse that no longer used pipeline for other things, right? Maybe putting down other conduits and so forth. So yeah, there's lots of possibilities.
One of the things that I would add on when we're talking about service life is if we're talking 100-year service lives, there's going to be maintenance associated with those pipelines. And most of the maintenance associated with the drainage pipe comes back to the joints. You can have 2.5 times more joints if you use a rigid pipe. It's just over the course of 100 years, you're going to be doing some maintenance on joints. I would prefer to have 2.5 times fewer. I think that would be better.
Fair enough. I might pose a question to the panel, and this one I suppose is more around looking forward with the sector. So where do you all see the role of plastic piping evolving over the next 5 to 10 years plus? So I might kick off with, I'll put someone on the spot. Anthony?
Well, hopefully we see more industry acceptance, and then that just opens up the door to use it in more locations. I think this is just an example of change that's coming. We need to be more efficient with what we're doing. Plastic pipes are longer, they're lighter, so the transport costs and everything is less. So if you look at that whole of cycle thing, it needs to be considered. Where we're heading, probably more sort of private-public partnerships to help fund some infrastructure. That's likely to drive some change as well based on price. That's my thoughts there.
Awesome, thanks. Dan?
Yeah, so I think one of the things is just generationally, demographically, younger people have been using plastics more than my generation did. I mean, the current young people have grown up on plastic park benches, on plastic gas cans, plastic car parts. I just think that the role of plastics for younger people is much easier to accept than for people with gray hair like myself. And so I think some of it is just a demographic shift, and I think that's going to be very positive. I think the other things that are important are, I think joint performance is very important, especially when we talk about from an environmental standpoint of losing water. I think the idea of containing water, even for storm drainage, is going to become more important, and having a joint system that is already watertight. I just think it from a long-term maintenance standpoint, it makes sense. From a sustainability standpoint, it makes sense. And then while I'm on sustainability, I think the use of recycled plastics is something that will become more and more. Carbon footprint will become more and more of an issue. And I think that plastics that can be fully recycled at the end of their life, or that can be produced using recycled content at the beginning of their life, are great ways to reduce carbon footprint and find a home for single-use plastics. And so I think those are some of the things that we'll be facing, and as well as continued development. I think it was stated earlier, somebody said, as an industry, we do continue to develop, and there's always something. There's always going to be something new, larger diameters, better joints. There's always going to be improvements because our industry continues to innovate.
Excellent. Thanks, Dan. Matt?
Yeah, I think just to add to some of Dan's points in regards to sustainability, that's definitely an important sort of future aspect of plastic pipes. We've got a good sustainability footprint in terms of carbon footprint, and it's in terms of circularity, in terms of its long service life, long potential service life, and what we discussed before about being able to recycle these materials. So we're extending service life into multiples of 100 years, in terms of the material in many cases. So that's something really exciting and something that specifies and should be aware of. And one of the things I'd sort of promote is making sure that you look to things like environmental product declarations, which a number of manufacturers have in regards to their products, and particularly corrugated drainage pipes, and that gives users information about the sustainability aspect of the product in terms of carbon footprint and other environmental performance measures. And in terms of the recyclability and incorporating recycled materials, that's a developing space. One thing that we always need to be mindful of when incorporating recycled materials is, material properties. Do they perform? There's work being done in the standard space to develop that further, so that whatever we do in terms of incorporating of recycled materials, we maintain the required properties to ensure that long service life, right? So that's really key. So there's more work being done in that space.
Thank you. Sandra, have I asked you? I don't think I have.
Yeah, of course. Yes. I think that I don't want to be very long, but I think that I agree with everything that has been said, especially when it comes to sustainability. But also, I do think that for me, it's important this thing with constant innovation that we have in plastics, and we can see the stormwater infrastructure already moving towards smarter systems, in greener solutions, and also to more strict rules when it comes to water quality and infrastructure resilience. So I can completely see plastic solutions being adapted to these trends, bringing solutions for these trends, being able to supply modular systems, complete systems, complementary to the pipes, that can bring that help the customers, help the stakeholders bring these solutions, follow the trends of the market. I think that innovation is a big issue about in our industry in plastics. So I can see how it will be adapted to the new trends.
Thank you. And Don, I'll give you the final word today.
Lovely. Thank you very much. What I've learned, particularly with some of the questions today and recently, is that as an industry, we've done very well to educate the designers and the contractors in the use of these sort of products. But listening to some of the questions and listening to some of the comments, particularly by Anthony, I think as an industry we need to provide maybe better training, better information, all the tools for local council or the asset owner or the approver of the product. So we'll put together some technical information, and we'll be knocking on the doors of these councils and approvers nationally. So I think that's what I've got out of today.
Wonderful. Look, I think that's all the time that we have for today. So please join me in a big thank you to our panel. So Don Tazewski, Sandra Perez, Dan Currents, Anthony Brodsky, and Matt Hines for their time and input. It's really appreciated. So thank you to you all. I'd also like to thank Engineers Australia's industry partner, Iplex, for their support today. On another note, I'm very excited to celebrate International Women in Engineering Day here in Engineers Australia, with events taking place across the country throughout June. So Keep an eye out on our website with regards to those events and opportunity to learn more and register based on your location. And finally, as per normal, if you could complete the short feedback form, which is linked in the description box below. If you could complete that for me, it really does help us to improve our future sessions for you, our audience. So finally, thank you again for joining us, and we hope to see you at our next Industry Partners event. Good afternoon.